The next section we're going to cover is tokens. I just want to slow down for a second to make sure that there's not any questions. If there's anything that I can clear up about this section, about accounts, about transactions, about Sol and LAMP ports, whatever it is, go ahead and throw those questions in there. I'll give you guys 1 minute to do that, a couple minutes maybe, and then we're going to move to tokens. If you need to use multiple programs in a transaction, you have to make a contract, I assume? No, actually. So if you look at the transaction format here, and if we look at it here, you can see that the instructions field is a list, right? So you can include multiple instructions in one transaction. In fact, that's usually preferable because it's going to be a little bit cheaper. And the way you determine different programs is with this program ID field. So if I have two instructions in one transaction and one instruction is pointing to the system program and another one is pointing to the token program, you can send them in one transaction and it'll go conduct operations on two different smart contracts. That's how you do it. There's no such thing as an instruction that points to multiple programs because it's not really how it's built. It doesn't really make sense, like it's one instruction is designed for one smart contract. So that's how you do it with multiple programs. How does it know how to hook up the inputs and outputs? So the inputs are in the instruction data field here. So to give you an example, like the system program is capable of doing a couple things. So let's consider two operations that the system program can do. It can allocate space and it can create an account, right? Which are two different things. Allocating space just, that doesn't involve like actually activating an account yet. But let's pretend those are two different separate things. What the smart contract is going to do, and we'll actually see this later live in Rust code, is it'll have a processor inside of it, which is some code that's going to take a look at this instruction data field, and it's going to deserialize it from bytes into Rust code. And it's going to take a look at what instruction it is. So in a very basic sense, think about an enum. If you have an enum that has three different variants, and each one is a command, one is create, one is allocate, one is transfer, right? If I can take that instruction data, deserialize it into that enum, and determine which variant it is, then I know what to do, right? If the variant is transfer, I know that I'm going to conduct a transfer. Now, what the tricky part is the accounts that I'm supposed to use to do that thing. That's what it's put in that accounts field, that list. And the weird thing about Solana is they have to be in order. So like you have to know that the order you need to put the accounts in for a transfer is you need to have the sender, the recipient, and the system program, or the owner. In this case, the system program, because we're going to the system program. They have to be in that order. And the code on the smart contract is going to read them in that order. If you have them backwards, it will fail because it'll try to send from your recipient, but your sender will be the one who have signed it. So it'll give you an invalid signature error. But it's a little confusing. It'll make a lot more sense when you see the on-chain code later. But yeah, basically think about the instruction data as almost like an enum that tells it what to do. And then the accounts are the different like data records or files that are going to be involved in that operation. And again, that will all make sense later.